Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today we proceed with lecture 10, that is here in the dynamics part of static and dynamics. And the first topic is rectilinear. That is part 1. Rectilinear part 1 because there are part 2 for rectilinear next lecture. Today motivational quote is fear Allah wherever you are. Do good deeds after doing bad ones. The former will wipe out the latter, and behave decently toward people. By Prophet Muhammad SAW, recorded by Imam Al-Tirmizi. Okay, previous lesson you have learned about 2 and 3 force member, 2D and 3D rigid body, moment couples, 2D and 3D moments, 2D and 3D forces. All of this is the static part. Static. So today lesson we will today introduction to dynamics. And the first topic in dynamics is rectilinear. So today we will learn about the terms related to dynamics. And for this, to learn about dynamics, we need to recap more on the mathematical equation, differential and integration. So the terms including displacement, velocity, and acceleration. Okay, let's recap first what you have learned. So for this subject is related to mechanics. So in mechanics there are two parts of mechanics, that is static and dynamic. Static is the branch of mechanics that concern with the forces in equilibrium, and dynamic is the branch of mechanics that concern with the effect of forces on the motion object. So for dynamic is motion object. So in static you have learned about particle and rigid body that include the 2D, 3D forces, moment, and reaction at body. Okay, so the other part of mechanics is dynamics, which we have kinetic and kinematic and kinetic, and kinetic including rectilinear, curvilinear, and relative motion. Okay, what is the difference between kinetic, kinematic, and kinetics? Kinematic is the branch of classical mechanics which describe the motion of point, bodies, and system of bodies without consideration of the causes of motion. So for kinetics, we not consider the causes of the motion, only have velocity and acceleration without the forces or torques which create the motion. So we don't care what is the forces that create the motion, just focus on the velocity, acceleration, displacement. So kinematic doesn't consider the mass of the object. However, for kinetic is a term for the branch of classical mechanics that is concerned with the relationship between the motion of bodies and its causes. So, compare with kinematics that not concerned about the forces create the motion. Kinetic concern the relationship between the motion and uh, the causes of the motion. So it's focused on the causes of different motion of object, such as in the rotational motion, force or torques that is deal with kinetic. So this is the comparison between kinetic and kinematic. So for kinematic, it's deal with, so for kinematic, deal with position, acceleration, and speed of the object. But for kinetic, deal with causes. So what you need to remember, and kinematic does not take into consideration the mass of the object. So no need to know the mass. But for kinetic, it take into consideration the mass of the object. For kinematics, its application can be found in the study of movement of celestial bodies, and for kinetics, its practical application can be found in the designing of automobile. So, for example, kinetic is more on bodies, but for kinetic it's more on automobile. So kinematic doesn't take forces explicitly into account, and kinetic take forces explicitly into account. And kinematic has more mathematical expression, and kinetic does not have more mathematical expression. Okay, kinetic also known as dynamic, and kinematic is a topic used in physics, mechanics, in terms of engineering. Like kinetic is used various branches of science such as biology, chemistry, and physical. Okay, as in dynamic, we have rectilinear, curvilinear, and relative motion. So rectilinear is rectilinear is the motion that particle move along a straight line, and for curvilinear, it's move along a curved line in 2 or 3D dimension. Okay, now let's look the terms that's used in dynamics. So first, you need to know the difference between vector and scalar. So for scalar only have magnitude, and vector have magnitude and direction. So for example, distance is how far you have traveled. So distance is scalar because we only have the magnitude how far you have traveled. That means the value of uh, distance. And the other one is displacement. Displacement is how far you are from your starting point. Positive or negative indicate the direction. So here is vector because it have magnitude, saying how far magnitude, and positive and negative indicate the direction. Positive indicate the toward right, and negative toward left. And the other one is speed versus velocity. Speed is how fast an object is moving, the rate at which an object covers distance. This means distance over time. But for velocity is the rate at which an object changes its position. Positive and negative indicate the direction also. So speed is a scalar and velocity is vector. So let's look for the first terms, that is position. Position is related to distance and displacement because in motion, in dynamics, we need to know where is the position of the particles. That particle moving along a straight line is said to be rectilinear. So rectilinear means straight line. So you have coordinate. Position coordinate of a particle is defined by positive or negative distance of particle from a fixed origin on the line. So for example, we have positive here. So P is in positive position and P um, apostrophe is in negative position based on the coordinate. The motion of a particle is known if the position of coordinate is known for every value of time. So if every time known the position, so we can uh, know the motion of the particle. So it can be expressed in terms of function such as this and graph x versus t. So the y-axis is x and the x-axis is t. Okay. So displacement versus distance. Okay, as I explained before, distance is okay, distance is scalar and displacement is vector. So for displacement, it can be positive and negative depend on where the position refer to the origin, refer to the point of reference. For example, here SA, SB, and SC. Okay, SB, SC, SA, SB, and SC is positive because it is at the right based on the refer to the O point. But SD is negative because it is at the left from the 0 point. And distance is scalar. So distance travel is travel from O to D. So where is the D? Okay, D is here and O is here. So O to D, it is SB plus SD. 2SB plus SD because here is okay, this is B, this is SB, but this is to because toward right and then rotate again toward left, so 2SB plus SD. So in the magnitude is not considered, so we only take the positive because it is scalar, so no need to know the direction. And from O to C, from A to C, from here to here is 2SB minus SA minus SC. And then learn about velocity. Velocity is the vector unit of the speed. So it's considered similar with the speed, but for velocity we have positive and negative direction. So from here, consider a particle which occupies position P at time t and P apostrophe at t plus delta t. So the average velocity is okay. The average velocity is delta x. That is the total distance over time. But for the instantaneous velocity, it's delta x over delta t. This can be positive or negative. Magnitude of velocity is referred as particle speed. So magnitude of velocity same as speed, but the positive and negative based on the direction of the velocity. From the definition of derivative, so we have v equal to dx over dt. So for example, it's given the equation for x is 6t squared minus t power of 3. So the dx dt is 12t minus 3t squared. So you need to know the derivative. So v is dx over dt. And acceleration is the changes in velocity. The changes in velocity. So the average acceleration is the rate at which velocity is changed. So acceleration is Vf, V final, minus V initial over time. So the unit is ms squared. So for velocity, the unit is ms power of 1. So so the acceleration ms squared. So consider a particle which velocity v at time t and v apostrophe at t plus delta t. So instantaneous acceleration is this one, and it's can be positive and negative based on for increasing positive velocity and decreasing negative velocity is positive. So okay, for example, increasing positive v is positive and decreasing negative v is positive velocity, but decreasing positive v and increasing negative v. So if the positive and increase is together, the acceleration is positive. Okay, here. This one decreasing. Decreasing, increasing positive, decreasing negative, it's become the positive acceleration. But if the decreasing positive, increasing negative, it's become negative acceleration. Okay, so this is for example, you have equation of v equal to 12t minus t 3t squared. The a is 12 minus 60, so a is dv over dt. Okay, for here, okay, this is the continuation of acceleration. For example, you have okay, like okay, this is the relationship between acceleration and the displacement. So from, okay, let's do from here. Okay, we have a equal to delta v over delta t, so also same with the dv dt, and this v equal to ds dt, so it's become d squared s dt squared. So from here, if for example it's given s, so to get v, you need to dv dt, and to get a, it's dA dv dt. Okay, need to understand the relationship from displacement to acceleration, and from a to get the v is fa dt integration, and to get s from v is v dt. Okay, and special note, when v equal to 0, the a is not necessarily 0, because a is the changing of the velocity, but when v is 0 but it's not changing the velocity, so the a is not 0. When v is constant, a is 0, because a is the changing. Need to understand the changing of velocity. Okay, so this is the relationship between position, velocity, and acceleration. For example, you have the equation of position is 6t squared minus t power of 3, and then v is dx dt, so you will have 12t minus 3t squared, and a is 12 minus 6t. So when at t0, you will have this. Just put the value of t inside the equation. So this is the example. Okay, function of acceleration. Okay, for acceleration, we can express the acceleration in three methods. In function of time, a equal to ft. In function of position, a equal to fx. And in function of velocity, a equal to fv. Okay, and acceleration as function of time, a equal to ft time t, and okay, a equal to ft, same as dv dt. So here is the technique to get the velocity by integration of acceleration is function of time. Also same here, this is the function of time of velocity, and to get the position or displacement you can integrate the velocity. And this one is the second method, that is acceleration as function of position. A equal to fx. Okay, for fx, the equation is okay, A equal to dv v dv dx. Okay, so for this one, how we get this equation, because okay, A, okay, first of all, okay, v is dx over dt, and then when we rearrange it, we will get dt is equal dx over dv. Okay, for why we arrange like this, because this one is a function of position. Function of position is x, so we want to have the um, dx, that is the, we can integrate or differentiate the v in term of x, so we can arrange like this. So a equal dv dt, this is the another equation, and we use this to here, but we arrange d to the upward because we want to cross the d, so we put here dx dt over dx and time with v. Why is like this? Because okay, dv dt is same with a. So actually we want to have the same equation, but we want to get the equation in terms of x or position. So this is actually a, and it's actually like this: a times 1 over v times v. So you will get a, but it's dv over dt dx times v. So you cross the dt, so you will get v dv dx like this. Okay, so this is the equation. So this is a equal v dv dx. So when you arrange it, you also can a also same as fx. So this one can rearrange, so v dv equal to fx dx, to rearrange the dx toward fx. So you can get this equation. This equation can be used to get the position and velocity if the acceleration is given as a function of position. Okay, the third function is acceleration as a function of velocity. A equal fv. So okay, a equal to fv, and then a also same as dv dt. So you can rearrange this. Okay, why this one put toward right and dt toward left? Okay, dt toward right, fv toward left, because this is v. So we want to integrate the v function, so that's why we use fv dv. So you will get like this and like this. Okay, you can integrate the function of fv with the basic integrate toward v to get the time. So this is another function. This one is to get the position or displacement. Okay. Okay, in the dynamics or rectilinear, you need to understand the term of speeding up and speeding down, because for speeding up, it's not, that means it's need to get the velocity and acceleration with the same direction. Positive, you will get speed up, or negative, this one is same, negative also speeding up. Okay, for opposite direction, positive, negative, okay, it's become slowing down, negative, positive, also slowing down. Okay, this one you need to remember, because most of us will confuse about this term. Okay, I think that's all for introduction to rectilinear. Okay, this is quiz. Just determine that this parameter in the green table, this is scalar or vector. Okay, you need to determine yourself, because after this scalar or vector is very important in dynamics. Okay, that's all. See you in the next lecture. Thank you. Assalamualaikum.